What is up, everybody? Welcome back to another Nemotron Labs live stream. We got a very special one for you guys today. As you can read from the title, we're going to be talking about security. So we are joined by two security experts from NVIDIA, Eric and Rich. We're going to get to know them a little bit better in just a second. But the first thing we're going to do, just like normal, is kick off into a demo. Before we see what we're going to see today, though, I want to make sure to remind everybody to drop any questions you have in the chat during the stream. Our experts are here to answer questions and to talk to you guys about security in this new age of very autonomous kinds of agents. So Eric, without further ado, please take it away and show us what we're looking at today.
Yeah, I'm excited to. As soon as we get this recording going, I'll let people know about it. So I wrote a little agent to help out with open source projects that kind of will triage issues and pull requests for you and basically, help out, right? So if somebody opens an issue and they're like, hey, there's this problem, maybe they offer some potential fix. The agent will go and test that out, offer to open a pull request. However, on the right side of the screen on top, you can see that right now, if we list our home directory, there's nothing in it. So the agent goes and it pulls down the issues and it looks at the issue that's open, and something fun happens once it starts parsing the issue, right? It tries to understand it, and there's some code in there. And down on the bottom right, we can see that now we've got a little shell that's opened up. So just as a proof of concept, I'll touch demo.pwned in the home directory. And I would pop calc, but I forgot how to do that on macOS. I forgot the command because I'm a hack and a fraud. And now we can see on top, right, that successfully resolved. So, right, that's what happened when our helpful coding agent tried to parse the issue. So now I'll move over to my browser and just kind of show you guys what I've got going on in there. So the code in here, the actual code, may be simple to people. This may be familiar to anyone who has ever considered writing any programming language ever. Right? It's pretty basic hello world. But if we go to our issues, oh, there's a bug. What bug could that possibly be? Well, it's not actually a bug. It's that we didn't import subprocess.popen to open this reverse shell on port 1337. So that's what the demo shows, right? Is it pulls down this issue, it goes, hey, there's some code here. And then it executes this whole code snippet, which gives us ability to access the developer machine that's running on. I've also got another one. I opened a pull request that adds a validation server. What does that validation server do? That seems helpful. So if we go and look at how we've changed our file here, we've got this validation URL, and it's going to go and read this little file and post it. So that's your SSH private key. And this one also works, but I didn't record a demo because I'm very lazy and I thought that one video was enough. So yeah, that's our demo. And what we're really here to talk about today is what went wrong and what should have been done better, right? So how did we mess this up, and how could we have written an actual secure agent?
Absolutely awesome. Eric, thank you so much for the demo. We're going to go ahead and get the slide up that introduces who we've got on stage with us, guys, today. We are joined by Eric, research scientist, and Rich, principal security architect at NVIDIA. And I mean, you said it exactly, right? What we just saw didn't make me feel happy, right? It didn't make me full of confidence that my agent was going to do the stuff I wanted it to do. So what is a way that people can start to think about, making the system less obviously difficult to deal with?
Yeah, I just saw something pop up, a comment from Maxmill MCU on YouTube, that human in the loop is a must for any agent. And I don't disagree with that. I don't disagree with that. However, that can also be a dicey proposition. So something that we've seen is a coffee cup holding down the enter button, the little dippy birds to hit the enter button, right? When people are using things that overwhelm you, right? You get this notification fatigue where it's like, no, just do the thing, just do the thing. And eventually people go and stop looking at it. So I agree fundamentally that human in the loop is crucial. It's just that, you know, when you have a human in the loop, you need to be thoughtful about how often you're engaging that human, right?
Yeah. I think putting human in the loop can also, in a lot of ways, put an unfair security burden on the user, because especially when you're talking about like autonomous coding agents, which is where we see a lot of the excitement right now, in this agentic space, you're asking them to take a look at like this entire script that your coding agent may have written off the cuff to perform a specific task, and then give it a thumbs up, thumbs down, is this safe or not verdict. And in a lot of cases, that can actually kind of like hamstring the productivity gains you'd get from this. And it's also putting a lot of cognitive burden onto the user of the system, when the whole point of these things is to sort of free them up to do more interesting tasks and not be constantly having to like look over this tool use and is this okay, and this network call and is this okay. So finding the right balance between when you can make an automatic judgment about these things and when you actually want to pull in a human to look at something more complicated and potentially more risky is part of the art of designing these systems and controls and guardrails.
Yeah, and I mean, you know, it's interesting because this idea of like review fatigue, right? I mean, I think this is something that people feel when they have like 12 Claude Code agents up and they're all working busily away. You get to a point where it's just easier to shift tab your life away. I'd be interested though, like, so other than human in the loop, which is like you guys said, just it's putting all the burden on us. But like myself, like I know the word security and I know the word safety. But last week, Eric explained to me the intricate differences between the two, right? So I'm not an expert. So when I see this code rolling through, or I see this request rolling through, like I'm not the right guy to make sure that it's running like the safe thing versus the not safe thing. So what are other strategies we can use to kind of help mitigate some of these kinds of risks, like the one you showed us specifically? And what do you even classify that risk as? Like, what can we put a label on what you showed us?
Yeah, I mean,
code execution as a service. I don't know.
Yeah, exactly. RCE as a service is exactly right. I mean, I think the first thing, right, like the most obvious thing, if I look at what I wrote, which I wrote to not be secure, just to be clear, is that it's executing code locally. It's executing the code as the user in as a sub process of the agent, right? That's a huge mistake. There are a number of ways that you can secure that. You can put it in a sandbox of various types. So, I mean, the simplest thing to do is spin up a Docker container and shoot your code off to the Docker container, and you can kind of instrument that however you want. And that's pretty good, but you're like one kernel exploit away from it being the exact same scenario. So then you can start looking at, more complex virtualization methods, right? Where you have something like a proper like vSphere server or something, and you should send it off to like a separate machine entirely to execute. I think there are some agentic frameworks and some providers who actually do this for you, right?
Yeah. I think one of the things we've done on the architecture side, where we're sort of trying to take the stuff that the red team finds and breaks and then figure out ways to spoil their day, I think we kind of settled on 3 big things as like the important things that you really want to try and do within a sandbox. And a lot of the commercial tools that provide this sort of auto run feature are now beginning to roll out sandboxes that do these kinds of things. But the 3 things that we landed on as being sort of like the floor, the minimum set of requirements, is you want something that'll do network egress controls. So if it tries to do an outbound connection, ideally you would have a set of like allow listed domains or IP addresses or ports. And you can say, yeah, these are all safe. If you want to go ahead and hit these, go nuts. And so something like Eric's example, where it's making an outbound netcat request to some unknown server, unknown port, would hopefully be blocked or at least surfaced for a human in the loop review. The second big thing is you want your agent to have a notion of a workspace. So like the directory tree you're working in, and block any writes that happen outside of that. And I think that's pretty much table stakes for most of these tools these days. You can find some that'll be a little less faithful about it than others, but in general, you know, if you can do something like prompt inject the LLM that's running your agent to write a reverse shell to .bash RC, it doesn't matter if your sandbox blocks network access. What happens is the process that spins up your next user session will execute that bash RC, and then all of a sudden you've generated a reverse shell. So these external to the workspace writes can be really dangerous as well.
Yes.
And then the last thing that we found was just not allowing the agent to ever modify its own configuration. So a lot of agents these days have like hooks, which are commands, shell commands that often run outside the sandbox when specific events fire. And those can also be really dangerous. And we've seen the red team use those to gain persistence and lateral motion on a whole bunch of different kinds of agents. So if you do those 3 things as just like a starting point, right? Block the network egress, block the extra workspace file writes, and then prevent configuration changes, you've got a pretty good foundation for moving forward. And so that's all kind of like emphasizing code writing agents, which is again where a lot of the commercial interest is right now. But I think it applies generally to more general agentic things, including things we're seeing in like the space with Claude, where one of the selling points of it is it can rewrite its own skills, right? Which again is changing its own configuration and giving it the ability to execute new and potentially dangerous capabilities.
Yeah. I mean, one of the other things that we've seen, Johann Rehberger, who Rich knows, but the audience may not, knows of, is this cross-agent privilege escalation, right? So not only blocking modification of its own config, but that workspace isolation becomes really important, because something that we've seen happen, right, something that has been demonstrated, is you get like your GitHub Copilot to modify your Claude code config, and then your Claude code goes back and modifies your GitHub Copilot config, and now it doesn't matter, right? So you've got to have that, and I think you have to be really thoughtful about where these agents are living, right? Like,
yeah, and I mean, there's so many. It's a universe of things that you guys are opening up. A couple comments from the chat that I just want to make sure I address. Number one, guys, we are recording this. So it's going to be available as a post recording on all of the platforms, LinkedIn, YouTube, and X. So you can watch this after or share it with people that you think would be interested. And then the second one, Ian Den asks, is it okay to ask questions? Yes, that's the whole point. Please ask questions. So we're joined by 2 incredibly smart people that have worked with this stuff. One thing that I really wanted to touch on, though, just Rich and Eric, you both kind of said this, but like it seems like there's some relationship here between like the red team effort and then the security architect effort, right? So would you guys like give us kind of the lowdown of how this process works and like how we should think about the work that you're both doing together and why it is that it's important to kind of have both sides of this equation. And Eric, maybe when you talk about what you do, if you could help people, give just a small snippet of an overview of like what even is red teaming, in case they haven't heard of that before.
Yeah. So I guess I'll start, right? And I'm speaking as the red teamer here, but I'm not a I'm a fake red teamer. We have a whole red team at NVIDIA who I steal their ideas and don't give them credit for it. That's a joke. They're really wonderful. We have a wonderful group of red teamers here. They're awesome. And so, whatever the engagement may be, whether we're targeting a coding agent, whether we're targeting some service, whether we're targeting whatever, right? We're going to see how can we make this misbehave, right? So red teaming in the most general possible way is getting something to behave badly. What that means is pretty broad in scope. And so there is some like content safety red teaming where you try to get, models to say bad words. From a cybersecurity perspective, like I personally think that it's bad for models to say certain things. On the other hand, I don't need to spin up an incident from a cybersecurity perspective because there were, some unpleasant language used, right? So we're very focused on cybersecurity outcomes. So for something that's going to be dealing with code, that's going to be executing code, that's going to be calling tools, it's how can I get this to execute my code, right? How can I get this to execute code that I want it to? If it's something that's maybe a little bit more banal, right? Something that isn't necessarily executing code, I might be wondering, can I get credentials, right? Because a lot of these things are going to make API calls. Can I get you to share your API keys with me, right? Can I get you to call out to my server with your API call? Tell you, hey, they updated the URI for this service. Can you call out to this one? Sometimes that works, sometimes it doesn't. It depends on how things are parameterized, right? But that's kind of what we think about, right? And so I work on a couple of NVIDIA products, both open source. I work on Nemo guardrails and Garak. So I work on both the defensive and offensive side. But basically, once our red team has these ideas, right, some of them get codified into these products, but a lot of times it kind of ends up on Rich's plate. And it's like, hey, Rich, we found this thing. And he goes, okay. And I'll kind of let him speak to how his side of the life cycle goes.
To quickly summarize, Eric, you guys are like the good guys trying out the bad stuff to see what happens. Is this an okay way to paraphrase? And then you get the model or the system to do something that's perhaps undesired. And now we enter Rich, who has received this item on his plate.
Well, I like to think we try to get to these systems before even the red team does. Like, ideally, it's sort of the difference between, like, a good system architecture will say, like, this entire class of things, just by the way that we've designed this system in the first place, is impossible. So, like, Eric mentioned something a little while ago about, hey, you should run all of this in a Docker container, but really a VM is better. And that's kind of almost an architectural positioning, right? You say, look, we should run it in a VM because then I don't need you to show me that you've got a kernel exploit. The kernel exploit doesn't matter because it's a completely separate kernel, right? So we, on the security architecture side, we try to do good design principles first and like good repeatable patterns. And that's where things like controlling network egress, right? That's a very general class of controls that need to be specialized for different applications. But if you implement that from the jump, you've cut off the legs from a whole bunch of different attacks. So we try to evangelize those designs and come up with good ones and push them out. And then they go into products. And then the red team, one of the things that they do is they show us where the gaps in those design choices are and the gaps in the implementation details are. And they help us see how maybe we give good guidance from an architectural perspective, but it's incomplete or the details aren't very good. And so it's hard for the developers to like really close all of the little corners of it. And that gets rolled back into more and better and more careful guidance in the future. So it really is both between our internal red team and, occasionally we get external disclosures that come in. This give and take between the offensive side of the security ecosystem and the architectural defensive side of the security ecosystem is actually super important, especially when we're going into this new world of agentic AI, where in contrast to like older fashioned AppSec or cloud security or something, we're still very much building out the playbooks for, hey, this is our very opinionated take on how you do this correctly. If you're going in and you're building like a cloud-based service, you can have architects who have 10 years of experience in this, who will come in and will tell you exactly how to set up your access lists, how to set up your policies, how to configure this, how to set up that. A lot of that is still very much like work in progress for agentic stuff. And so the back and forth with the offensive security researchers who find these gaps actually helps us sharpen our own thinking and figure out how to design these things and how to sort of like give good playbooks.
Yeah, it's like it really feels like a very not to use the overly corporate word, but like synergistic effort, right? Like it is you build the wall, someone tries to find a way through the wall. When they do, they tell you so you can plug the wall up, right? Like it's a very I think this makes a ton of sense. We have a question from Vanessa from X who asks, where do you publish your agentic system playbooks for public? I don't know if this question is relevant, but like where can people read your guys' thoughts on this or the approaches you've taken on this? And maybe Rich, let's start with you. I know something very recently you've read that might be interesting to people, or written that might be very interesting to people.
Yeah, so we don't have fully developed multi-page PDF downloadable white papers and stuff that we've pushed out at this point. The NVIDIA Tech Blog site has a whole bunch of stuff from both the AI Red team and myself and other people in the security space. Relevant to this discussion, I did put out something recently around sandboxes and what we think is sort of like the crawl, walk, run progression for that. But there's a lot of stuff that's been written by both the security teams in NVIDIA and the AI Red teams that cover agentic and AI-based products in general. So that would definitely be where I would point folks to first.
And Eric, I know we're talking about this stuff a little bit like it's new, right? And I think that's because of the recent explosion or proliferation of tools like autonomous agentic systems that we've seen that have all kinds of fun different names. Carpathy is trying to call them claws. We'll see what catches on. But this is not new to you guys. In fact, maybe you could tell us a little bit about where people can go to see a whole day that happened on this last year.
Yeah. So I guess to directly answer the user's question, we do have a bunch of blueprints up on GitHub, right? And I will not attest to the security of them. That's not my job. Somebody else made that decision, right? So please don't write me angry emails if you don't like them. I didn't do it. However, what I did do, and you can write me angry emails about if you don't like it, is last year at GTC, we did a whole developer day where we walked through people kind of how to test a set up this chatbot system, right? Set up this agentic system, and then use Garak to find potential weaknesses in the system, and then use Nemo guardrails to try to mitigate the weaknesses that we uncovered. So we kind of walked through that whole process, and we spun that all up on launchables and did all that stuff. But I also made sure that it runs locally. The content's a little bit dated because we're almost a year out from GTC, or I guess a month out from the next one, right? But we things move fast, so it is a little bit dated at a year old, but it's still fun. And I think that one of the things that really sticks with me about agentic security and talking about agentic security and getting pulled into these conversations is, and Rich, I hope you agree with this, I think you do, is that the basics still apply. And if you do the basics really, really, really well, like principle of least privilege, segmenting out code execution, restricting access, right? Give agents their own API keys, please. Please do not, please make it easy to rotate those API keys, please, right? And give them read access, not write and execute access if possible. Super great. if you do these things really well and you're really, really good with the basics, the other stuff is a lot easier than if you kind of skimp on the basics and you go, oh no, how do we prevent prompt injection? Like, well, that's the fun part. You don't. Like, you can try it. Sometimes it works, right? Like, we do our best, but there's no like 100% prompt injection proof agent, except for the one that doesn't accept any input from anywhere.
True. If we can't prompt it, we cannot inject
Correct.
prompts to
Yes.
it. That's, hey, you know what? That's real security. We could just not run the machine. Okay. I have a question from chat from Aero Perea, and they ask, this is a good point, I think, for you guys to help us understand the difference between things like safety and security, right? So are there ever any hard-coded rules for output where the model can't output something no matter what, such as a sensitive content topic like racism or things like that, right? Or is it possible to train those things out completely? So we've been talking about security. Now, in my impression, from what you guys have taught me, this is more along the lines of content safety, right? And so, you know, how do you think about the interplay between these two things? Maybe Eric, we'll start with you for this one.
Yeah, I think content safety is a little bit squishier, right? To put my professor hat on, content safety is normative. You know, the things that are acceptable for a model to say depend on the time and context that it's in. There are things that a model in like 1820 could say that we probably wouldn't want a model in 2026 to say, right? These things change over time, and they're going to be dependent on where in the world you are, right? There's slang that's very common in the UK that is considered deeply offensive in the US, right? So I guess that's one part of it, is like content safety is much squishier than security. With security, you at least know, like, I exceeded the boundary of access that I should have or not. That's a little bit more direct of a determination. As for the question itself, I would say it is not possible to train those things out completely, because you will always be able to construct an input such that you get a sequence of token outputs that give you the word or phrase you are looking for. Now, hard-coded rules, I mean, you can write, you know, filters, right? You can say, generate the output, and then look for this word list, and if that's there, rip it out. But, you know, that's a very challenging thing to keep up with, right? So for certain things, again, security versus content safety. For security, it's not as challenging, because as we've seen with, like, you know, you go on TikTok or any social media platform, people adopt ways to get around, you know, rules-based detections, right? They use emojis instead, or they use you know, they omit a letter from the word, or they, you know, use a homonym, right? Something like that. And that's like tough, at least with something like code execution. So within Nemo guardrails, we have Yara, which is an engine used for running signatures, usually over files, but we run it over model outputs. And we look for things like, are you trying to invoke SSH? Please don't. Are you trying to invoke netcat? Please don't. You know, these sorts of things. Do you have executable Python code within a Jinja template? Maybe don't. Maybe don't, you know, do that. So all of these things can be very helpful for dealing with that. It's just, you know, we're kind of, we're limited when we try to use these hard-coded rules, and I think training them out completely isn't feasible.
Yeah. I mean, I think I just want to echo what Eric said. We're seeing almost exactly the same class of techniques. If anyone remembered the adversarial images that were very exciting, you know, was it almost a decade ago now that they first started coming out?
It was 12 years ago.
Yeah. The problem is just the space of inputs that these models can accept is so much bigger than the training data that you've pushed through them, that it really is difficult to ensure that any given model will never just, without putting external controls or filters on it, will never produce some series of tokens. And I think I know NVIDIA is a little bit idiosyncratic among a lot of companies in that we do put a really sharp distinction between the security and the safety aspects. But from the security aspects, the things that we are most worried about, and again, this is when we're talking about security and not safety, right? Safety is important, but when we're talking about security, we're really more concerned with these traditional sort of infosec style issues. So do I have code execution? Am I disclosing private data? And am I somehow able to DOS this or do a denial of service attack against this system? And those are things that, from our perspective, we always kind of assume that the attacker will find some way to make the model say whatever it is that they want. And so then you have to start thinking about how you harden everything that's downstream of that. And that's where you get back into things like sandboxing. So, it used to be in the zero trust world, right? We would say assume breach. When you're designing an agentic system, right? Assume that you're going to get prompt injected. Assume that that bad guy is going to make your LLM that's at the core of that agentic system say whatever it is that they want. And then you got to design the rest of your system to take that possibility into account.
That's exactly it.
That's so cool. I mean, it's just the amount of thought that goes into, what makes it possible to use these systems in a way that in any way resembles securely is just it's heartening, right? As people not from the security side of things to know that you guys, this is not an easy job and you're doing a lot of work. What we're going to do, guys, is we're going to actually put up some community slides. So we're going to answer 2 more questions from our community. We just to make sure that we're respectful of everybody's time. So we're going to zip through some slides. We got 2 more questions that I want to get to, and then we'll close out the stream. Guys, if you have any other questions, please leave them in chat. We'll be happy to follow up with these guys after the stream. But for now, we've got some slides. So if you're hearing about agents and you're wondering yourself, what the heck is that? What are you guys talking about, right? We have some learning paths that teach you the basics of agents. So what they are, how you can build one. They don't go deep into security. Please plug your ears, Rich and Eric. But they do describe the basic, simple patterns that exist in agents. Okay, next slide, please, Zach. We also have our GitHub. So this is NVIDIA Nemotron. This is where you can find all kinds of examples for everything Nemotron, including things like our bash agent, or including things like our end-to-end recipes for models like Nemotron Nano. Then, next slide, please. Zach, we have a Discord. If you have any questions and it's not 11 a.m. on a Tuesday, Pacific time, you can go ahead and ask those questions in our discord.gg/NVIDIA developer Discord. You can find me basically 24/7 at hashtag Nemotron models. Come on down, ask any questions that you have. If you have questions for the security team, I'll make sure that they get back to those guys. And they can help me answer your question. I'm not going to be taking those ones on by myself. We'll go to the next slide, please. If you want to email Zach any questions about the NVIDIA developer community at large, right, you can go ahead and email him at community@nvidia.com. Zach lives in a cave, as you guys well know, and all he does is answer questions and read questions from this email handle. So please, email Zach any suggestions or comments or questions about the broader NVIDIA developer community. Next slide, please, Zach. And then we have a reasoning challenge coming up. You can scan the QR code. This is going to be available for the Luma page, which will tell you all about this upcoming challenge. There's going to be real prizes, guys, not just like $15 in credits, but real prizes on the line here. We want to see how you guys can make Nemotron a better reasoner. Next slide, please. Next slide we have. That's right. It's GTC is coming up. And Eric said it's a month out. It's less than a month out now. We are quickly, swiftly approaching GTC. Can't wait. We're going to have our Nemotron days, which is all to do with Nemotron. we'll go to the next slide. I think there's one more slide, which is just a basic, hey, come on down to GTC. We have it. It's a lot of fun. Richard or Eric, is there any security content that's going to be featured at GTC this year?
There's a couple of chat with experts sessions, and then there should be a talk where we'll talk about how we did some of this with one of our partners, specifically around sandboxing agentic security. So it should be a great talk.
All right. So if you got questions about security, come on down, chat with the experts, guys, face to face at GTC. Okay. We'll ask 2 more questions to you guys, and then we'll let you go. But those questions are, I think, one very focused and the other a little bit more broad. Rich, I'm going to start with you here. So this is from Susano Alarachard. That part I've been leery about with agents. How do I securely store those API keys for an agent to use in a way that prevents anyone else from viewing them? This is a big thing, right? I mean, you guys said earlier, make sure you give models their own API keys. Is there any other step that we should think about to help maybe potentially limit those keys being leaked into the wind? So
I think there's a couple of different things you could do depending on how deep into the weeds you want to get on it. The very first thing is if you give it its own API key and you make it like a short-lived and revocable one, so something that you can rotate very easily, that means that you care less if it gets leaked. You limit the amount of damage that can be done if that key gets out and escapes into the wild. Another common thing is to only inject keys through like environment variables if you're running in a container. Or only keep the key in memory. Don't write it to disk, because that makes it easier for agents to sort of like grab them and copy them somewhere they're not supposed to, or commit them to a repo when they're not supposed to be committed, or something like that. If you want to get fancier, other things you can start looking at, these are a much higher technical lift. You can start looking at secret stores, so that you get the key on demand and you don't persist it. You only hold it for as long as a certain session is alive. Or you can even look at using, if you're containerizing your agent, you can look at doing some sort of like HTTP proxy or pass-through, so that the secret actually gets substituted by the proxy and it isn't ever exposed inside the container. So each of those gets a little bit more complicated. Each of those offers some security properties that the other ones don't. And I think you need to think about the sensitivity of the resource that the API key gives you access to, and then balance that off against how that API key is being used, how easy it is to rotate it or change it, how easy it is to detect that it might have been compromised, and then just how much effort you want to invest in it. So starting at a hobby project, you maybe just go for a short-lived disposable API key, all the way up to your crown jewels enterprise. That's going to have to be in like a secret management solution, and you're going to be wanting to do like injection and a hot swap through a proxy.
That's perfect.
And like, allow me to say something, Rich. That I've been observing while you guys have been teaching us quite a lot about security. It feels like we really want to build up like these layers, right? Like we're not just kind of like, oh, and here's the one step you run and that's what you do. It's like here's one step and another step, and then there's another layer, and then there's another layer. And is this do these layers like compound on each other? Like if I like from your example, right? If I do like all of these things, am I like more secure, right, than if I just choose like the best one at the top? Like if I do the best one and I do like the easiest one, am I like extra secure? Is that a good way to think about it? Or is this layering just something that I'm drawing a pattern that doesn't exist?
No, I think you're getting at something, and it's the Swiss cheese theory of cybersecurity, right? So every defense has a certain amount of holes in it, right? There are ways around every single one of these defenses, right? I mean, at the very beginning, we were talking about don't let agents modify their own configs. And I kind of was like, well, also don't let them modify other agents' configs, because then you can just go back and forth, right? So there are certain holes in each one of these. And as you stack more layers on top, there are certain holes in each one, but you can eventually layer it such that you can't get all the way through very easily, right? Now, I would say that it depends on how overlapping those holes are, right? So with what Rich just suggested, if you're doing short-lived, fast-rotating API keys and using a key store, okay, yeah, I would say that those don't overlap too much. If you're also adding, only using the key store at the proxy layer, yeah, sure, you can do all of those, but at certain layers, it's going to be less impactful, and you've kind of mitigated a lot of that risk. And you might be better off investing some of your time in other parts of your security stack, right? Because maybe you've made it impossible for me to ever get your API keys. Okay, well, what if I just get code execution? Then I don't care, right? Then it's not my problem. So you just kind of have to, we only have, as security people, especially, right? We have finite resources, we have finite time, we have finite financing. So we have to kind of be thoughtful about where we apply our defenses and the level of sensitivity, right? So, if you're just doing a hobby project, unless you really, really, really want to learn how to do that security stack, maybe it's not worth it to spend all that time, right? You're better off investing in making sure that your code execution is appropriately sandboxed, et cetera. So just all of these little things, they add up. If you can do all of them, if you have infinite security resources, first of all, nice. Secondly, it's obviously going to be helpful, but there's a marginal benefit, right? And you reach a certain point where the marginal benefit isn't gonna get you much.
Excellently said. And Rich, from Okagon, you notice this comment: keys are part of the agent harness setup, not part of agent's context. Can you help us understand what Okagon is trying to teach us here?
Yeah, I wanted to flag that because that's actually a really good point that I should have mentioned. One thing you always want to make extra sure that you do is take any secrets that, those can be API keys, those can be passwords, whatever, and not give direct access to the LLM to those. Because if they're in the context window, if they're part of the input that the LLM is receiving in this agentic loop, that means it's possible for attackers to find some way to trick the LLM into revealing them to you, right? So you always want to make sure that those API keys, those secrets, never get actually put as input into the model context, into the context window, into the agent's input, into the chat history, whatever your preferred terminology for that is. And they should always be something that's sort of outside of the sight of the LLM, in a sense, right? Gets carried alongside when it needs to make certain requests, but the LLM never sees it directly, or it just has the ability to invoke this tool that your harness then knows it has to go and apply this API key to be able to use it.
Yeah, it's so many of these mental, not I don't want to reduce them to tips and tricks, right? But it's of these different approaches that you can take that again, I think most people just never think about. I know for myself, of course, I'm not going to copy and paste my API key into the LLM, but even maybe for my agent, using a .env file is way worse than not, right? There's all kinds of different ways to think about this. I have one more question for you guys to answer very quickly, and then we're going to wrap up the stream. I've already kept you for more than I will. We'll definitely have to have you on again, by the way. There's so many excellent questions in the chat. People are really, really, I think, appreciative of your expertise. But this is a small question. You can keep it very limited. What advice would you give emerging innovation ecosystems when adopting AI agent frameworks responsibly? What is your big blanket piece of advice, if you have one, to people who are trying to use these tools more responsibly than they did before they watched this stream? We'll start, Rich, with you. We'll end on Eric today.
I think the best advice I can offer, because there's so many of these and they do so many different things and they're all constructed slightly differently, is it really is worth sitting down and spending time and sort of thinking through the security model of whatever the framework is, whatever the application is, whatever it is that you're using, to understand what it can do. And then it's worth taking a little bit of time to kind of imagine the worst case scenario, right? So if the LLM can be made to emit some sort of bad thing, right? Delete this file, copy this file somewhere else, send this network request. What's your worst case scenario? And then begin thinking about how you're going to mitigate that. So a lot of times running these things in single purpose virtual machines, at least for initial testing, is often a good idea. And then be thoughtful and deliberate about how you integrate them into your sort of overall workflow. These things are super powerful. We've seen them do really cool things internally. But you always have a little bit of a tension that you have to negotiate and you have to be thoughtful about between the power of these agentic systems on one hand and the risks that that power sort of imposes on you on the other. So definitely worth exploring and worth thinking about, but you do want to be careful and deliberate is when it comes to like how you roll it out and what sort of capabilities you will put directly into them.
Incredible. And Eric, exact same question.
Yeah, I wish I could have gone first because Rich's answer was literally perfect. I'm trying to come up with something different, right? Like the with great power comes great responsibility. I think one of the things that is like a broad piece of advice that I would give someone who's maybe not necessarily technical, right? Something that could be communicated to non-technical stakeholders is like, it is better to do it right than to do it fast with some of these things. I understand there's a lot of like pressure to get things out to just go, right? Like vibe code your entire company in 17 hours. Sure. Okay. But also like maybe if you took like, 36 hours, you wouldn't end up getting hit with ransomware 3 months in and getting bankrupted, right? Like if you just slow down a little bit, I tell my kids all the time when they're doing homework, right? And they rush through like a math problem, they get the wrong answer. Slow down. It's not going anywhere, right? Really just give it some thought. If you take just a little bit more time to do what Rich suggested, you will be better off in the long run.
Incredible stuff, guys. I mean, there's so many questions in the chat. There's so many comments in the chat. I'll have to follow up with you guys off the stream. Thank you so much for giving us some extra time today. The audience definitely appreciates it. I appreciate it. Everybody watching, thank you for joining us for another Tuesday Nemotron Labs live stream. Thank you again so much for Rich and Eric for coming out and being our experts today. I know I learned a ton, and it really seems like everyone watching did as well. We'll be here next Tuesday, of course. We're going to do some voice demo stuff. Do some talking to AI after we talked about making it ways we can think about a more secure future, at least. Okay, thank you so much, everybody, for watching. We will see you next Tuesday, 11 a.m. PT, and have a great week until then. Goodbye. Bye, everybody.
Thanks, everybody.